In this video, we're going to talk about solving trigonometric equations using algebra as well as our unit circle. So we're going to be finding exact values of an equation that may look like this or similar to this. A couple notation things. If you see an x, that means it's all reals and you're solving for in radians. If you see a theta, that means, hey, we want to solve in degrees. If it says for all x or for all theta, think about the unit circle. We know that, for example, here, sine is 1/2 here, it's 1/2 here, and then I can start the circle again and it'd be here. So like it's at 30 degrees, but it's also at 390 degrees. It's also at 360 degrees more. So there's an infinite number of angles that would result in those values, which is why we'd say, okay, plus 2 pi k or plus 360k, because we're saying, hey, it's plus however many circles you want to go around. But the key thing there is if it says for all theta or for all x. That's when you do these. And so if you remember, the period of sine and cosine is 2 pi or 360 degrees. And that is why tangent is either pi or 180 degrees, because that's the period of tangent. Let's get into our first example. So our first example says find all exact solutions for sine of x equals 1 over square root 2. Something else to remember is it's not just 1 over square root 2. You can also see this written as square root 2 over 2, which is how it kind of shows up on one unit circle, and other unit circles show it like this. So it really doesn't matter which one. But since it says find for all exact solutions and we're in x, we're going to be looking in radians, and we want to look at the entire circle to find where sine equals this. If I pull this up, sine equals that right here at 45 degrees, and sine equals that right here again at 135 degrees. But keep in mind we want radians, so it's pi over 4 and 3 pi over 4. Down here our signs are negative, so it's pi over 4 and 3 pi over 4. So we're going to write x equals pi over 4, x equals 3 pi over 4, and because it says for all, we're going to say plus 2 pi k. K representing how many circles we can go around, plus 2 pi k. So I've got these two answers, and those would be my two answers I'm looking for here. So let's look at another one, or another two. Now on these you may have to actually solve and get those equations by themselves. On our first one here, we know that if we want the cosine by itself, we need to add the 1 and divide by 3. And it says find exact solutions, if not possible, approximate to 2 decimals. All right. So we're going to figure this out. So cosine of x equals 1 over 3. Now the problem that I can foresee with this is cosine does not equal 1/3 anywhere on this circle. So we're going to visualize our circle here. Cosine is our x value. So let's draw our circle in here. We're going to go and draw this triangle here and just assume that this right here is 1/3, because that's our cosine. We also know that cosine would be a positive 1/3 mirrored down here, just like this, because it's positive 1/3 regardless. Our calculator is going to give us this measure. So if we were to do cosine inverse of 1/3, so cosine inverse of 1/3, and because we're in x, we need to be in radians. So make sure your calculator is set into radians when you do this. And you will end up getting, let's see here, x equals 1.23. All right, it does not give us a domain, and it says find all possible, so we're going to go ahead and do a plus 2 pi k. That 1.23 is this angle right here. We also know that going this direction would also give us that. So I could say x equals plus or minus this, because I've got the positive one and the negative one, or what I could do is figure out in turn, let's see if I can figure out what is this angle. So it's a full 2 pi. I'll minus out that 1.23. So I literally will do 2 pi minus the answer I just got. And that gives us 5.05. So x equals 5.05 and plus 2 pi k. Once again, I have two answers. Running out of space. And these are my two answers. Okay, so let's try the tangent one over here. We can see tan, or square root 3 tan equals 1. So all I would need to do is divide by that, square root 3. So I've got 1 over square root 3. Now, if you recall yesterday when we talked about this, tan is sine divided by cosine. So all I have to do, if the denominators are all the same, is divide the tops. So 1 over square root 3, root 2 over root 2, square root 3 over 1. I'm looking for 1 over square root 3, which is this pi over 6. Now, was I supposed to be in degrees? I'm supposed to be in radians still. All right, so this is on the unit circle, and I can use that. For tangent, I'm only looking within the period, so I only need to look in this top half, or this section right in here. Because remember, tan inverse works with these. Or in one half the period, so I could look in both of these. It really doesn't matter. But tan is 1 over square root 3. So right here, pi over 6 would be my answer to that. Oh, and I didn't even see, I forgot the x. Okay, so x equals pi over 6, and then because it's tangent, all I have to do is plus pi k. That takes care of that. That's my only answer right here, is this one right here. All right. So if you have more involved equations, then we'll have a more involved process to getting those. Our first thing we would need to do is to really try and solve for the specific function first, and then these are some of the other ideas that you can do. So feel free to pause or screenshot this so you have this. Well, let's talk about this one. We have two different things going on here, and so we are going to have to use our algebra. So I would say let's start with factoring. And I'm actually going to give us a domain to work in. I'm going to say, hey, and this would be given to you, by the way. I'm going to say we're going to work from 0 to 2 pi. So I only want to find one loop, which means I don't need to do the plus 2 pi k at the end. But I do need to solve this. If I look at both of these, I notice they both have a sign. So using my algebra idea, I'm going to factor out the sine of x. That leaves me with another 2 sine x, and then plus 1. Don't forget that plus 1 equals 0. So I've got two equations to solve. I've got sine x equals 0, and then I've got 2 sine x plus 1 equals 0. So if I were to solve that, then I've got sine x equals negative 1/2. I'm looking for two different things. I'm looking for sine is 0 as well as sine equals negative 1/2. So back to our unit circle. Sine is our second one. So sine equals 0 at 0 and pi. Again at 2 pi, but we're already there. So 0 and pi. So I'm going to come back over here and write that. So x equals 0 and x equals pi. Now where does sine equal negative 1/2? Well, here positive, 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 negative 1/2 right here. So sine equals a negative 1/2 at 7 pi over 6 and 11 pi over 6. So I'm going to come right here and I'm going to write x equals 7 pi over 6 and x equals 11 pi over 6. I do not need to do the plus 2 pi k because I gave you where you need to look. And the problems would do that, but here I've got 4 answers. Now the only other thing we might want to do is check for extraneous solutions. And this is very easily done, especially if you have a TI graphing calculator. So give me a minute for mine to set up here. what we would do is in our y equals, we would type in these two equations. So I'm going to have 2 sine squared of x. So sine of x, close parentheses, squared, plus, I believe it was just sine of x. And that is equal to 0. So what I would do now is I'm going to go to second graph. If you cannot type numbers into this, here's a shortcut. Second window takes us into our table set. We want to go down here to independent, and we want to say ask. Now I should be able to type whatever values I want into this table. So I'm going to check these. So the first thing I'm going to do is check 0, 0, 0. Then I'm going to check pi. Pi is not 0. So notice pi doesn't give us our answer we want. So that one's going to be extraneous. I'm assuming I typed that in right. Yep. So pi is extraneous. It doesn't work. Then we're going to try 7 pi over 6. Oh, actually, let's check one more thing. Hey, looky there. We need to be in radians. That's the other thing we need to do. I thought these should all work, actually. There we go. Now it works. All right, so 7 pi over 6. That one works. And then it was 11 pi over 6, I believe, is the last one. And that one works. So all 4 of those do work, as I thought they should. So make sure that you are in the correct mode on your calculator before you check these, because you could see what happens. You get answers that don't work. All right. So that's how we use algebra to kind of factor it out. This one requires us to use, and see, this is what I mean by it will give you the domain to work within. I just wanted to do a shorter one last time. All right, we're going to have to use our trig identities here, and that's going to be very important. So using our sine 2x, remember this is 2 sine x and cosine x. And that's still going to equal our sine x. So if I were to move everything over, I'm going to have 2 sine x cosine x minus sine x, and now we're equal to 0. This allows me to look and see, okay, do I need to factor some things out? Well, they both have a sine x. Let's try and factor that out. So if I factor out sine x, that's going to leave me with 2 cosine x minus 1. And that's equal to 0. So my two equations I'm going to be solving are going to be sine x equals 0 and 2 cosine x minus 1 equals 0. But if I were to solve that out, really it's going to be cosine of x equals 1/2. And those are what I'm going to look for on the unit circle. Once again, I'm still with x, so I want to be in radians. Go to my unit circle. Sine x, we found those last time. It was 0 and pi. We can go ahead and put those. X equals 0, x equals pi. I'm going to come up here and grab that. All right, so now we're going to find, where does cosine equal 1/2? Well, cosine is a positive 1/2 right here. So at pi over 3, negative, 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 negative. Oh, and 5 pi over 3. So pi over 3 and 5 pi over 3. So x equals pi over 3. And x equals 5 pi over 3. Because, once again, it tells you what domain to work within, these are your only two answers. So we'll box these in. You can check for extraneous again, sine 2x. This one's a little bit different because it's got an equals. So sine 2x. I didn't mean to do that. Sine 2x. And then the other side was just sine x. Still in radians, so I don't have to change it. 0 works, pi works. We got those. And then the other ones we need to check are pi over 3 and 5 pi over 3. They have to equal each other here because I have two different sides of the equals. So I'm going to come down here and do pi over 3. That one works. And then it's going to be 5 pi over 3. And those work. So all 4 of these, once again, are answers. And this is just generally what you're going to do for these equations. You're just going to keep going through and solving. This one's a little bit special because if you recall, this has a square root in it. So you'll end up squaring and foiling and doing a bunch of stuff like that. And those are the main ones that we're going to talk about here. So if you have any additional questions, feel free to hit me up during my office hours. And I wish you luck on solving these trig equations using algebra.